Hey guys, this is Mrs. Harbin, and this is Algebra 1, Section 6.5. Today we are going to talk about parallel and perpendicular lines when we are talking about slope and linear equations. For a quick lesson opener, let's take a look at these and state the slope of each linear equation. So for y equals negative 4x, hopefully you picked out very quickly the slope is negative 4. But what about when y equals negative 3? What does that look like? Hopefully you remember that when y equals any number and there is no x, then your slope is just 0. That is our horizontal line on Mr. Slope face here. And what about x equals 7? Again, when there's just one variable, the line is not slanted. It's either horizontal, like y equals negative 3, or it's vertical. So 7 is like that. And a slope of a vertical line, hopefully you remember, is undefined. Now let's describe the graph of each function. How would you describe x equals 7? X equals 7 is a vertical line, and y equals negative 3. That is a horizontal line. X equals 7 is a vertical line through x equals 7 on the Cartesian plane, and y equals negative 3 is a horizontal line that goes through negative 3 on the y-axis here. That's a quick sketch of what those two would look like. Our biblical integration for this unit is this. God provided 4 different gospel accounts in His holy word that provide us different insights to the same story, the story of Christ. They were written for different audiences. They focus on different perspectives. Graphing equations helps us to see written information from a different perspective. We can see that information in the form of a table, or in the form of a chart, or even in a graph. And that helps us to see trends, and it helps us to make predictions about future events or future trends. Our lesson objective for today is that you, the student, will write the equation of a line using point-slope form, using a point on a line, and the equation of a line that is either parallel or perpendicular to it. Now, we've been talking about different forms of equations, different linear equations. And the first form we looked at was standard form, ax plus by equals c. And we found that by plugging in 0 for x, we could find the y-intercept, or by plugging in 0 for y, we could find the x-intercept. We would then have 2 points, and we could connect those points to make our line. Remember, standard form uses integers, no fractions, and typically our leading coefficient is not negative. Slope-intercept form, which is what we've been working with for most of this unit, is written in this form, y equals mx plus b, where this b represents our y-intercept and the m represents our slope. By graphing b, we can then count our slope, like if it were negative 2, down 2 and over 1. Put a point there, and again, connect our points to graph our line. So that is slope-intercept form because it tells us the slope and the y-intercept. The third form for a linear equation is called the point-slope form. And we use this form when we know a given point, not the intercept, and we know the slope. So slope-intercept is specifically 0 and whatever the y-intercept is. Point-slope could be any point, not an intercept, and the slope. And it's written in this form. Y minus y1 equals m times x minus x1, where our x1 and our y1 represent the point that we know, and our m still represents slope. This y and this x are the variables that are going to stay in the equation. The point-slope form provides an alternative method of determining the equation of a line from the slope and any given point on the line. We could use the y-intercept, but typically we use this when we don't know an intercept. An equation of a line passing through negative 5, 2, and 3, negative 4. What if we wanted to write that equation? Well, the first thing that we need to know is the slope. So we're going to use our slope formula, m equals y2 minus y1 over x2 minus x1, and we're going to plug in the numbers that we know. Again, I would definitely recommend that you label your x1, y1, x2, y2 to make sure that you're keeping them in the correct order and plugging them into the correct place in the formula. Also, even though they don't do it here, I would recommend that you use parentheses around your numbers to protect your negatives. So negative 4 minus 2. And 3 minus negative 5. You can see they did use parentheses here. That just helps make sure we're putting our negative signs where we're supposed to put our negative signs. When we simplify that, we get negative 6 over 8, which can be reduced, since both of those have 2 as a factor, to negative 3 over 4. All right, now that we know our slope, we're going to use one of these points. It doesn't matter which one, but one of these points, and plug it into our point slope formula. We have y minus y1 equals m times x minus x1, and we're going to substitute one of our x's, one of our y's in the m. It's important that we use the x and y that are together. We can't use this x and this y. We've got to use ones that are listed together as coordinates. So let's go ahead and use this one right here. So for our y1, we're going to plug in negative 4. Notice that we use parentheses to protect our negative. We have our slope, negative 3/4, and our x minus 3. Let's go ahead and simplify. And the way that we're going to simplify, y minus negative 4 becomes y plus 4. And then we distribute our negative 3/4 to get rid of the parentheses on the right-hand side. So we get negative 3/4 x plus 9/4. Remember that when you're multiplying fractions, so negative 3/4 times negative 3, that a whole number or an integer is just this number over 1. And we multiply across the top, and we multiply the denominator. So negative 3 times negative 3 is 9, and 4 times 1 is 4. And that's where that positive 9/4 comes from. From this point, we need to go ahead and solve for y, which means we need to subtract 4 from both sides. Now, we can't just take 9/4 minus 4. We know that with fractions, we have to have a common denominator. So we need to change 4 so that it has a 4 in the denominator. If we want to change that to 4, we can do this, move this little arrow here and say, okay, I want to change it to 4. Multiply that by what's on top and get your new number on the top here. So I want to change my 1 to a 4. 4 times 4 gives me 16. It's kind of like you're starting at the bottom of a z and working your way backwards. So 4 is the same as 16/4. So we're not going to subtract 4 here. We're going to subtract 16/4. And when we do that, we get y equals negative 3/4 x minus 7/4. Because 9 minus 16 is negative 7. The fourths just indicates the size of our pieces, if you will. So the denominator doesn't change there. All right, if we wanted to change that to standard form, we would need our x and our y on the same side and no fractions. So the first thing that I would do would be to multiply everything by 4. That would get rid of my fourths on the bottom. And when I do multiply everything by 4, I get 4y. 4 times negative 3/4 is just negative 3. And 4 times negative 7 is just the negative 7. So the fourths will cancel out there. We then need to move our x over to the other side. So we're going to add 3x to both sides, and we get 3x plus 4y equals negative 7. So that's how we change that from point slope form to slope-intercept form, and finally to standard form. Now here are some definitions for you. Parallel lines, you should know, are lines in the same plane that have no points in common. They have the same slope, but different y-intercepts. They run side by side, but because they have the same slope, they will never cross. Any line that has a different slope will eventually at some point cross, but parallel lines will never cross because they have the same slope. They do, however, have different y-intercepts. You can see this top line has a y-intercept of 2, and the bottom line has a y-intercept of negative 1. So they are parallel, they have the same slope, but different y-intercepts. So let's take a look at the relationship between these two lines. Without graphing, what we can do is put them in slope-intercept form. We can then look at the slopes to see if they're parallel. So we're going to do that to both sides. We're going to go ahead and solve for y. On the left, we get y equals 3x minus 6, and on the right, we get y equals 3x plus 4. Our slope for the line on the left is 3, and our slope for the line on the right is 3. Our y-intercept on the left is negative 6, and our y-intercept on the right is 4. As you can see, these have the same slopes and different y-intercepts, so they are parallel. If they had the same y-intercept, they would be the same line, or coinciding. But these have different y-intercepts and the same slope, so they are parallel. Let's find the equation of a line that's parallel to a given line passing through the given point. So first we want to find the slope of 4x plus 3y equals 17. And we're going to do that by putting it into slope-intercept form. Once we do that, we find that our slope is negative 4/3. We know that a parallel line is going to have the same slope. So we want to write an equation for a line with the same slope, but our line is going to pass through this point. We know a slope, we know a point, so we need to use point-slope form. Using point-slope form and plugging in the numbers that we know, we get y minus 9 equals negative 4/3 times x minus negative 5. Let's simplify that by combining our double negatives there and distributing, and we get y minus 9 equals negative 4/3 x minus 20/3. Let's go ahead and put that into slope-intercept form by adding 9 to both sides. Now, just like we did on the previous slide, we can't just add 9. We need to add 9, but written in a way that it has 3 as the denominator. So if I wanted to change 9 to a fraction with 3 as the denominator, I'm going to use that backwards Z. I'm going to go from 1 to 3, and 3 times 9 is 27. So 9 is the same as 27/3. Now I can combine those two things, and I get y equals negative 4/3 x plus 7/3, because negative 20 and positive 27 is a positive 7/3. Let's talk a little bit about perpendicular lines. Perpendicular lines meet at right angles. They form 90 degrees. And because they form 90 degrees and meet at right angles, there's something special about the slope. Their slopes are negative reciprocals of each other. The negative reciprocal of a number, a, is negative 1/a. So the negative reciprocal of 3 is negative 1/3. The negative reciprocal of 1/3, flip it around, is negative 3. If you flip it so it's a reciprocal and you change the sign, that's what a negative reciprocal is. If our original slope was negative 5, the negative reciprocal of that would be, flip it, 1/5, and change the sign from negative to positive. So negative reciprocal, you flip the number, that's what a reciprocal is, and change the sign. Perpendicular slopes have negative reciprocal slopes. Perpendicular lines have negative reciprocal slopes. Let's try a few here. Hey, if your number is 8/5, what would your negative reciprocal be? Hopefully you said negative 5/8. If your original number is 9, what would your negative reciprocal be? Hopefully you said negative 1/9. What about if your original number is negative 13/7? What would your negative reciprocal be? Well, we just flip it and change the sign. 7/13, and it's a positive. If our number is a, what would our negative reciprocal be? Negative 1/a. Remember that parallel lines have the same slope, but perpendicular lines have a negative reciprocal slope. Let's write the slope-intercept form of the equation of the line perpendicular to this line, but passing through to 7. So the first thing we need to do is identify the slope of this line. The slope of this line is negative 4. So a line perpendicular to it, the slope of the line is negative 4. The slope of the perpendicular line would be what? Hopefully you said 1/4, and that would be positive because we flip it and we change the sign. So the slope of the perpendicular line is 1/4. Now we know our point and we know our slope, so we can use point-slope form. Let's go ahead and plug in those numbers. We have y minus y1 equals m times x minus x1. Plug in our 7, our 2, and our 1/4. Then we're going to distribute the 1/4 to get rid of the parentheses. And finally, isolate the y by adding 7 to both sides. Now, 7 is the same thing as 14/2, so you see a plus 7 here, and a plus 7 here, just written as a fraction. When we simplify that, we get y equals 1/4 x plus 13/2. And we were asked to write it in slope-intercept form, so we are done. Let's take